Black holes are some of the most astonishing and mysterious objects in the universe. They form when massive stars collapse after their cores can no longer sustain nuclear fusion. Black holes possess such immense gravity that nothing, not even light, can escape their pull. This is why they are referred to as black. They neither emit nor reflect light. There are various types of black holes, depending on their mass, charge, and spin. The smallest ones are called micro-black holes, though black holes exist even in our own galaxy. These objects are the subject of intense research in astrophysics, cosmology, and the theory of relativity. They present numerous physical and philosophical challenges, like the information paradox, singularity problem, and time loop paradox. Today, we'll dive into one of the most exciting and perplexing questions surrounding black holes. Where does everything go once it enters a black hole? What happens to matter and information that gets absorbed? Are they preserved or do they vanish forever? Can we recover or retrieve them in some way? I will attempt to answer these questions using modern scientific theories and hypotheses. The event horizon is the boundary around a black hole beyond which nothing can escape. This is due to the extreme gravitational force of the black hole, which not even light can outrun. The size and shape of the event horizon vary depending on the type of black hole. The simplest type is a non-rotating, uncharged black hole, where the event horizon is a perfect sphere. For a black hole with the mass of the Sun, the radius of this horizon is around 3 kilometers. If a black hole has charge or spins, its event horizon becomes more complex. Such a black hole can have 2 event horizons, an outer one and an inner one. The outer horizon is not spherical but elongated due to the spin, while the inner one resembles a ring with an empty center. The distance between the horizons changes depending on the black hole's charge and rotation. The event horizon can only be crossed in one direction, toward the center. Once you've crossed it, there's no turning back. An observer outside the black hole can never see what's inside. They can only witness the last light emitted from an object falling into the black hole. This light gradually fades and dims due to the black hole's gravity, eventually disappearing entirely. The event horizon presents many intriguing problems, such as the information paradox, the firewall problem, and the twin paradox. These arise because different observers may see different things happening inside and outside the black hole. So, what really happens to everything that falls into a black hole? This remains one of the most puzzling and complicated questions in modern physics. There are several hypotheses, but none have been fully confirmed experimentally or theoretically. Still, let's explore a few of them. One hypothesis suggests that the information entering a black hole isn't lost but is instead preserved on the surface of the event horizon. This is known as the holographic principle. According to this idea, nothing actually happens inside the black hole. All the processes can be described on the two-dimensional surface of the event horizon. Another hypothesis proposes that the information absorbed by a black hole is not destroyed, but transported to another region of space-time. This is called the wormhole hypothesis, suggesting that black holes are gateways to tunnels that connect our universe with another universe or another part of our galaxy. There's also the Hawking radiation hypothesis, which claims that the information entering a black hole can be retrieved when the black hole evaporates. Black holes, according to this theory, emit quantum particles that carry information about the absorbed matter. However, this information is extremely difficult to decode and restore. But what happens when something crosses the event horizon? That's when spaghettification takes place. This is the process where objects falling into a black hole are stretched vertically and compressed horizontally, like spaghetti. This occurs because the gravitational force near the black hole is uneven. It's stronger closer to the center than farther away, tearing objects apart in the process. Spaghettification depends on the size and shape of the black hole. If it's a large, spherical black hole, the process happens near the surface. If the black hole is smaller and more elongated, the stretching occurs farther from its surface. In the case of a rotating black hole, spaghettification happens even further from the surface. This process affects all types of matter and information entering a black hole, stretching them into thin, long strands and erasing their original shape and properties. The objects also emit light and other forms of energy, which are dragged into the black hole as well. Nobody knows what happens to this matter and information once inside. It's one of the greatest mysteries of physics. What comes next after the spaghettification? That's where singularity comes in, the point or region where the laws of physics break down. At singularity, matter and information are crushed into an infinitely dense and hot state, and space and time become distorted beyond recognition. No one knows what really happens at this point, as no signals or light can escape from it. Singularity isn't exclusive to black holes, though. For example, there's the singularity thought to have existed at the beginning of the universe. According to some theories, it was from this singularity that the universe was born. All the energy and matter that exist today were once compressed into a tiny, extremely hot point. In this state, density and temperature were also infinite, and space and time did not exist. Then the Big Bang occurred, and the universe began expanding and cooling. This is known as the cosmological singularity. Perhaps we were all once inside a black hole, and somehow we were lucky enough to escape. There's also the idea of future technological singularity, when machines become so advanced and intelligent that humans can no longer control or comprehend them. At that point, they would begin improving themselves and creating new technologies that are beyond human understanding, potentially causing significant changes to society and culture, or even leading to the end of humanity. As you can see, singularities present many questions and challenges, revealing the limits of our knowledge and capabilities. They also make us question our place and role in the universe. Today, we explored one of the most thrilling and complex questions surrounding black holes. What happens to everything that falls into one? We learned that black holes have event horizons beyond which nothing can escape. We saw that objects falling into a black hole get stretched and torn apart like spaghetti. We delved into the singularity, where the laws of physics no longer apply. We also discussed various hypotheses that try to explain what happens to the matter and information absorbed by a black hole. It's clear that the question of where everything goes remains open and controversial, with no definitive or conclusive answer. Science has yet to provide a full and accurate explanation of black holes. New theories and experiments are needed to help solve this enigma. Black holes remain one of the universe's most extraordinary and puzzling phenomena, prompting us to reflect on our place and role in the cosmos. Do you have your own hypotheses related to today's topic? Share them in the comments below. Oh yeah, and don't forget to subscribe and press the bell so you don't miss anything.